Assalamualaikum and good day to Dr. Fajrina binti Mansur. My name is Putrina Ila Auni binti Abdul Rahman. Today I will be presenting about pipeline transportation with a focus on the Putra High pipeline fire incident that occurred in 2025. First of all, let me begin by explaining the meaning and function of pipeline transportation. Pipeline transportation refer to the movement of liquids, gases, and ancillary material through long-distance pipeline. It is commonly used to transport natural gas, crude oil, petroleum product, water, and various industrial chemicals. This mode of transportation operates continuously and efficiently, making it essential in supporting energy supply, industrial process, and public utilities. In this presentation, I will discuss the characteristics, advantages, and disadvantages, infrastructure and networks, policies, stakeholders, as well as the issues and challenges involved in pipeline transportation. By examining this component, we can gain a clear understanding how pipeline systems function and why they play a vital role in national development, energy reliability, and industrial activities. This discussion is also linked to the Putra High pipeline fire incident in 2025, where a gas pipeline in Subang Jaya ruptured and causes a major explosion and fire. The incident damaged nearby housing, vehicle, and public facilities, and disrupted gas supply in surrounding areas. Investigation revealed that the pipeline failure was caused by soil instability, showing how structural weaknesses and environmental focus can disrupt pipeline operation and lead to significant safety and economic impact. Now begin with the first component of this topic, which is the characteristic of pipeline transportation. Pipeline system has several key characteristics that make them unique. Firstly, they operate continuously 24 hours a day with minimal human supervision, allowing a steady and reliable flow of products. Secondly, pipelines have high volume capacity, meaning they can transport extremely large quantities of oil or gas, often replacing thousands of tanker trucks. Thirdly, although pipelines require high initial construction costs, their operational costs are low, making them cost-effective in the long run. Next, pipelines are commodity-specific, where each pipeline is designed for particular type of product, such as oil, gas, or water, and cannot be easily repurposed. Lastly, most pipelines are built underground or subsea, which reduce visual impact but make inspection and maintenance more challenging. After looking with its advantage and disadvantage, pipeline transportation offers several important advantages. Firstly, it is continuous and reliable, as pipeline can operate steadily regardless of weather condition or traffic disruption. Secondly, pipelines have low operating costs. After installation, they require minimal maintenance and there are no loading or unloading delays, which help save time and manpower. Thirdly, pipelines are high energy efficiency because they consume much less energy compared to road tankers. Next, pipelines are safe for transporting hazardous materials, as they have a lower risk of spill and are equipped with leak detection and pressure control system to prevent accidents. Lastly, pipeline transportation is environmentally friendly. Since most pipelines are installed underground, they help reduce noise pollution, traffic congestion, and air pollution. Despite this advantage, pipeline transportation also has several disadvantages. The first disadvantage is high capital investment, as construction, land acquisition, and safety systems require very high costs. Second, pipelines are inflexible. They can only carry one type of commodity, and changing routes or expanding the network is difficult and expensive. Third, pipeline pose leak and environmental risk. Corrosion, technical fault, or illegal tapping can lead to leaks or even explosions. Next, there are security and safety concerns, as pipelines are vulnerable to sabotage, thief, flood, and landslides. Lastly, pipeline operation face regulatory and cross-border complexity, which requires coordination with multiple agencies and compliance with strict environmental regulation. Now move on to the next component, which is the infrastructure and network that support pipeline operation in Malaysia. Malaysia has several major pipeline hubs that play an important role in gas processing, refining, and petrochemical activities. One of the main hubs is the Kerteh Gas Processing Complex in Terengganu, which serves as a central processing point for natural gas. Next, the Pengerang Integrated Complex in Johor functions as a refining and petrochemical hub. The Gebang Industrial Zone in Pahang is another major petrochemical hub, while the Bintulu LNG complex in Sarawak is a key center for LNG processing and import. Malaysia also operates several major pipeline networks. The first is the Peninsula Gas Utilization or PGU system, which spans about 2,500 kilometers across Peninsular Malaysia. This network connects Kerteh to states such as Pahang, Selangor, Johor, Negeri Sembilan, and Penang. Another major network is the Sabah to Sarawak Gas Pipeline or SSGP, which stretches 512 km from Kimanis in Sabah to Bintulu in Sarawak. There is also the Kerteh to Gebang Petrochemical Pipeline, which transfers petrochemical products between important industrial complexes. In addition, the Langat to Water Transmission Pipeline supply treat water from Selangor to Negeri Sembilan. The main routes in Malaysia pipeline network include the PGU truck line, which runs from Kerteh to Pahang, Selangor, and Johor. The SSGP route connects Kimanis in Sabah through the interior regions and ends in Bintulu, Sarawak. For petrochemical transport, the key road links Kerteh to Gebang, while the Langat to Water Supply road connects Selangor to Negeri Sembilan. Next, I will move on to the policies that regulate and support pipeline transportation in Malaysia. This policy ensures that pipeline operations are safe, well managed, and compliant with national standards. There are several important policy and regulation that govern pipeline transportation in Malaysia. The first is the Petroleum Development Act 1974, which gained Petronas exclusive right to explore, develop, and transport petroleum resources in the country. This act also ensures that all activities follow national safety and environmental standards. The second policy is the Gas Supply Act 1993, which was amended in 2016. This act regulates the gas supply industry and introduced the third-party access system, allowing open access to pipeline infrastructure to promote competition in gas distribution. Next is the operational policy for right-of-way or ROA. This policy ensures that pipelines are built at safe distance from communities, utilities, and buildings to protect public safety. Another important law is the Environmental Quality Act 1974, which requires major pipeline projects to undergo an environmental impact assessment. This ensures environmental protection, proper pollution control, and effective emergency planning. Lastly, the CIMA regulation, which stands for Control of Industrial Major Accident Hazards, sets strict safety standards for operators who handle hazardous materials. This regulation focuses on risk management, emergency response, and ensuring the safety of workers and surrounding communities. After looking at the key policies that regulate pipeline operation, I will now continue with the issues and challenges commonly faced in pipeline transportation. There are several significant issues and challenges related to pipeline transportation in Malaysia. The first issue is mechanical fail and aging infrastructure. Many pipelines in Malaysia are aging, which led to mechanical fatigue, lag, and potential fires. Incidents such as the one of Putra Hardline how welded joint can fail due to repeated ground movement and pressure. The second challenge is geohazard and soil instability. Areas like Sabah and Sarawak have unstable terrain, soil movement, erosion, and landslide can damage pipeline and increase the risk of major lag. The third issue is monitoring and maintenance challenges. Although operators like Petronas follow strict maintenance standards, continuous inspection of long distance and older pipeline requires high cost and advanced technology. Next, this is the challenge of emergency response delay. Shutting down gas supply during emergencies takes time. Any delay can worsen the impact of incidents such as fire and explosion. Lastly, third-party interference and construction activities. Construction and excavation activity may accidentally hit underground pipeline due to poor condition. Next, I will move on to the stakeholder involved in pipeline transportation and the technologies they use to ensure safe and efficient operation. Pipeline transportation involves a wide range of stakeholders from government agencies to communities. Firstly, government agencies play a major role in regulation and monitoring. These include the Ministry of Energy Transition and Water Transformation, PETRONAS, the Department of Occupation Safety and Health, or DOS, the National Water Service Commission, or SPAN, and local authorities such as City Council and Municipal Council. The second group of the stakeholder is the transport operator. This include Petronas Gas Berhad, Gas Malaysia Berhad, gas operator in Sabah and Sarawak, water supply operators such as Air Selangor, SAJ and JBA, as well as private pipeline contractor who manage construction and maintenance. Next, we have the passenger or consumer, which consists of industrial users, commercial businesses, and residential consumer who rely on pipeline infrastructure for energy and water supply. Another important stakeholder group is the environmental organizations such as the Malaysian Natural Society, WWF Malaysia, and ECONOC, who monitor environmental protection and advocate for safer pipeline practices. Lastly, community organizations like resident association, Rukun Tetangga Indigenous Communities Group in Sabah and Sarawak, and volunteer safety group also play a vital role, especially during emergencies and public safety operation. Different stakeholders also use various technology to monitor, protect, and manage pipeline system. Government agencies rely on technologies such as pipeline integrity management system, SCADA, based on regulatory monitoring, remote lag detection, and GIS mapping for risk identification. Transport operators use more advanced operational tools, including SCADA system, smart sensor, and flow meter that monitor pressure, vibration, and temperature. They also use intelligent PIG or internal inspection and automatic shut-off valves to isolate pipeline during emergencies. For consumer technology, such as smart gas meter, home or industrial gas leak detector, and digital usage monitoring apps help improve safety and track consumption. Environmental groups use tools like air quality monitoring sensor, gas dispersion modeling software, and GIS based on environmental mapping to assess risk and environmental impact. Lastly, community organizations depend on emergency alert system, CCTV, and remote surveillance near pipeline roads, as well as communication system for volunteer and first responders. After discussing the stakeholder and the technology involved, I will now relate this component to the real incident that occurred in Putra High in 2025. In April 2025, a high-pressure underground gas transmission pipeline owned by Petronas Gas Berhad ruptured near Jalan Putra Harmoni in Putra High. The rupture caused a massive explosion and fire that could be seen by several kilometers away. The blast created a large crater measuring 21 by 24 meters, damaged hundreds of homes and vehicles, and disrupted gas supply across surrounding areas. This accident involved several key components of the pipeline system, including the gas transmission pipeline, the valve and control system, the distribution network, and surrounding infrastructure. Several stakeholders were also involved in managing the situation. Petronas Gas Berhad as the pipeline operator, where regulators such as the Energy Commission and local authorities provide oversight. Emergency responder, including the police, medical team, and the fire and rescue department, play a critical role in managing the explosion and ensuring public safety. Additionally, highway and transport operators were involved due to the impact on nearby road network. The incident had several significant impact on pipeline operator and community safety. Firstly, it caused high economic and social costs as the damage to housing, vehicle, and public infrastructure increased recovery expenses. Secondly, there were transport and mobility disruption, including the temporary closure of the section of the elite highway for safety reasons. Thirdly, the explosion led to reduced operational efficiency. The pipeline system had to undergo an emergency shutdown to isolate the affected section, which stopped the normal continuous flow of gas. Lastly, there was a major disruption of energy transportation affecting household, commercial area and nearby 300 industrial customers who depended on the gas supply. After understanding the event and the impact of the Putra Heights pipeline explosion, I will now explain the issue and the challenges that were identified from this incident. The first issue is pipeline leak and environmental contamination. When a pipeline leak, it can contaminate so that water sources produce strong odors and create potential health hazard for nearby communities. Secondly, the accident caused disruption to public safety and daily activity. Repair work required surrounding area to be closed off, forcing residents to change their daily route and routines. The third challenge is community concern and trust issue. Many residents were worried about the long-term safety of living near a pipeline after such a major explosion. Fourth, the case revealed slow lag detection, which exposed weaknesses in the monitoring system and the lack of effective nearly warning sensors. Lastly, the emergency response. The repair operation were costly. High operational costs were needed for pipeline repair, spill cleanup, and continuous environmental monitoring. Based on this issue, several recommendations can be made to improve pipeline safety and prevent similar incidents in the future. The first recommendation is the strengthen pipeline monitoring and early detection. This includes installing real-time sensors, pressure monitor and lag detection system, as well as using automatic alert for remote monitoring. The second recommendation is to improve preventive maintenance. Egging pipeline segment in high-risk or densely populated areas should be replaced, and scheduled inspection should be conducted using advanced tools such as smart peaks and ultrasonic testing. Third, emergency response preparedness must be enhanced. Faster response protocols should be developed with clear SOPs for reporting, containment, and cleanup. Collaboration with local authorities such as the fire department, police, and environmental agents is also essential. Finally, community communication should be strengthened. This includes providing timely update to residents through SMS alert, mobile application, and official announcement, as well as organizing community briefings to rebuild public trust and educate residents on safety procedures. In conclusion, the Putra Heights pipeline explosion highlighted the urgent need for safer, more efficient, and well-monitored pipeline system, especially in densely populated area. The incident disrupted daily life, caused environmental risks, and raised significant public safety concerns. By improving monitoring technology, enhancing preventive maintenance, and strengthening communication with the community, future incidents can be minimized or even prevented entirely. Effective collaboration between pipeline operator, local authorities, and residents is crucial to maintain public trust and ensure the long-term safety and reliability of Malaysian pipeline infrastructure.